Hello everyone, this is our visual programming final project presentation and we choose the title The Twilight Wave. My name is Jolin Li Jianyi.
And my name is Lim Rou Qing. We chose this poem because in our final project we'll use the element. We chose this poem because it conveys deep emotion and meaningful themes in a powerful yet simple way. The poem speaks to universal human experiences such as beasts, universe, waterfall, or nature, which make it easy for reader to connect with on a personal level.
The project title is Waving. The artist statement Waving is an exploration of ephemeral state at the continuous dance between chaos and form, drawing inspiration from the inherent fluidity of natural phenomena, the subtle undulations of a hazel, the relentless push and pull of ocean currents, or the vibrant pulse of an aurora. This work seeks to capture movement not as a linear progression, but as a perpetual state of becoming. This is the reference and case study, and this our YouTube video link, and this is design progress network of pitch. The design process is sort to chop analysis, convert the sort from grid 1 into a chop, often used to manipulate geometry point positions or send data to other chops. RAM top analysis creates a vertical or horizontal gradient, often used as a base, pattern, or mask. Displays top analysis displays RAM1 using noise tree. This is used to work the gradient. This is next design process, the noise top analysis. Noise to likely generate a black noise pattern. Given its output preview, it appears to be primarily black, possibly indicating a specific type or range of noise, or it might be configured to output very low values. Reorder top analyze, reorder likely, reorder or remaps the color channel, example red, green, blue, alpha of its input. It receives input from node 3. Its output preview shows a vibrant red and blue gradient, indicating that reorder 1 is transforming the black input from node 3 into a color gradient. Add top analyze. Add 2 also add the pixel value of its inputs. It receives input from add 1 and noise 6. The final output preview remains a red and blue gradient, indicating that noise 6 does not visually alter the gradient from add 1 significantly. And the next design process is point sprite matte analyze. Point sprite 1 likely a geometry sprite top or a Rayleigh component that generate a sprite-like visual, possibly used as a texture or an element on the 3D geometry. It's connect to point 1, suggesting it's providing a texture for a point material. Camera light comb analyze. A camera comb and light comb This defines the viewpoint for rendering the 3D scenes and the light source in the 3D scenes. Its output connect to render to top to sort, analyze, top to one converts data from a top texture operator format to a chop format. It's connect from below, implying it's taking visual data and converting it into channel data, which then fit into Ad3. Next, design process network of universe. Select chop analyze, select likely, select a specific input which appear to be generating some kind of animate multi-color pattern. Judging by the small preview icon, this input then fits into noise 2. Trace top analyze. Trace is which converts input pixel to either black or white or two distinct values based on a specific threshold level. It takes input from constant 5 and output to multiply 1. Multiply top analyze. Multiply likely multiplies the pixel value of its inputs. It receives input from trace 1 and select 2. The output of multiply 1 is then feed into feedback 2. This is the feedback log, and also potentially into Ad2 through the connection is slightly obscure. Vector direction top analyze. Vector direction likely calculates vector direction from its input, which appear to be the output of the ads left to right node. The preview shows a green-blue pattern output suggesting direction data. Mattop analyze. Mattop perform mathematical operations on pixel values. It takes input from X1 left to right side and output to X1 top right. Its preview show a grainy black and white patterns. Add-sort analyze. Add5 likely performs an addition operation on its input. Its preview show a blue square with scattered white right blue dots, suggesting it might be combining a base color with positional data or particle. Bloom top analysis. Bloom top adds a glow effect to bright areas of the image, enhancing the visual appeal of light source or luminous elements. It preview show the blue point with a slight glow. Transform top analyze. Transform top and allow of for scaling, rotating, and translating the image. It's applied after bloom effect. Its preview shows the bloom point, possibly slightly adjusted in position or scale.
And the next is the design process of the network of the show. And the next page is Cam1 camera comp analysis represents a virtual camera in the 3D skins showing a view of the blue points. And another point is grid twist noise factor now analysis. The row of blocks on the left grid twist noise factor. Now, this row of blocks is responsible for creating and deforming an object. It starts with a simple grid, then twist it, add some random variations noise, and make it more complex fractal. And the next page is the design process network of the show and the transform SOP analysis. This is a transform SOP is used to manipulate the sphere position, rotation, and scale in 3D space and making it larger, small, or rotate it. The particle SOP analysis, it is the core of the particle system. The particle SOP is responsible for generating and simulating particles. And the next point is the null SOP analysis, often used to clearly mark the output of a section of the network or to make it easier to connect to multiple downstream nodes without creating tangled wires from the particle one node itself. And the next is noise theorem analysis. It generates a postural noise pattern. In this setup, it is connected to the lookup TOP and is used as an input to influence the color lookup process to provide it with a texture. And the next is RAM top analysis. It generates a linear or radial color gradient. And the next is null2 top analysis. The null2 top serving as a placeholder to clearly mark the output of the processing chance before it goes to the final display. And the next place, and this is the network of flowy flowers with particles GPU. And the next is the design process. The RAM top analysis generates a gradient and it could be used to create color variations or marks. The transform top analysis, the position, scale, and rotation of the image are manipulated in a feedback loop to slightly offset, creating motion and smearing effect. And the next is level 2 and lookup 2 analysis. Through level 2 and lookup 2 for final color grading, contrast adjustment, and overall visual polish before being sent to the out1 operator for display. And the next page is design process of flower. The null1 top analysis, a null top used as a placeholder to clearly mark the output of the main generative sections before it proceeds to future processing or the final display. And the next is transform top. These transform top are in a feedback loop, applying transformations such as slight rotations to the image feedback each frame. And the feedback top, a feedback top takes its output and feeds it back into its own input, creating continuous animations, trail, and complex generative patterns. The swirling colorimetric nature of the large central image is a hallmark of a well-tuned feedback loop. And the noise2 top analysis, it is connected to noise1 by a dotted line indicating a reverse connection or parameter reference rather than direct image flow. This means that node1 may control a parameter of node2 and vice versa. The two noises are added together to display certain aspect of the final image. And the next is Mesh1 top analysis. The Mesh1 top, a Mesh top performs mathematical operations on image channels is connected to noise2, suggesting that the output of noise2 is being numerically manipulated before being used further down the line for displacement or color mapping.
This is our still image. And thank you.
And thank you, teacher.